Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. So now we are entering chapter 7, ionic equilibria, which mainly we will discuss about acidity, basicity, and the reaction involving the acid and base, salt, buffer, and also ionic equilibria. Sorry, not the solubility product. Okay, so the pH, what we can see here is the pH of various items uh, with the range of pH from 0 to 14. Okay, so this is the example that what kind of item that have a different pH. Okay, so firstly about this chapter, you need to know uh, what is the theory uh, okay, of the acid and also the base. Okay, so the first theory, okay, the first theory is what we call as the Arrhenius theory. So this one is the first theory. So Arrhenius theory states that acid is a substance that produces H plus when it dissociates in water. So HCl aqueous will dissociate in water to produce H plus and Cl minus. So you can see here, if you have what we say the H plus, the proton, and the proton will dissociate, okay, dissociates and produces H plus and Cl minus. So this is the first theory of acid and also the theory of base, okay. Base is the substance that produces, okay, hydroxide ion when it dissociates in water. Alright, so the first theory. So the second theory is the Bronsted-lowry theory. So Bronsted-lowry theory is the theory that explain, okay, uh, acid is the species that donates, okay, donates a proton. In this case, the proton is H plus, okay, H plus to another species. Meanwhile, base for the Bronsted-lowry is the species that accept a proton to another species. For Bronsted-lowry acid and Bronsted-lowry base, we need to write an equation. Okay, so for example, we have NH4 plus react with H2O as the reactant. So for the reactant side, we must have the acid and also the base. And for the product, uh, we must have the conjugate base and conjugate acid. So conjugate acid, conjugate base, conjugate base and also conjugate acid shows that this is the Bronsted-lowry acid-base pair, okay, for the reaction. So how do we identify the pair that related, okay, to each other in the reaction? So here we can see NH4 plus, okay, since it consists of nitrogen atom, it is paired with ammonia NH3. So you draw the pair, okay, and H2O and H3O plus will be another pair. So if NH4 plus donates a proton, so donates a proton to a base, so acid will form conjugate base. Meanwhile, base that accept the proton will form the conjugate acid. Okay, so we will look it again in another example. Okay, So the third theory is what we call as Lewis acid-base theory. Lewis acid and Lewis base theory. So Lewis acid is the species that accepts the electron pair to form a dative bond. So this is the difference between Arrhenius, Bronsted-lowry, and Lewis. So Lewis, we are talking about electron pairs. So if the species accept electron pairs from another species, it is called as the acid. Okay, acid. Okay, for the example, we have BF3. So BF3 here is the species which has only 6 electrons around the central atom of boron. So means that less than 8 electron, lack of electron. Therefore, it has the tendency to form a dative bond with another species or the species from NH3. Okay, so NH3 will donate the electron to BF3. So NH3 is the base and BF3 the acid. So we have the product here. BF3 NH3 is the product with the dative bond. So this is the difference between Arrhenius, Bronsted-lowry, and Lewis. All right. So next, we can look at one of the question, the exercise question for 7.1.1. Okay, we can try. Okay, question 1C. Okay, we try 1C here. Okay, so PO4 3 minus react with H2O and producing HPO4 2 minus and OH minus. So how do we solve this type of question? Because we need to identify the acid-base conjugate pairs. So the acid-base conjugate pairs, firstly, you identify the pair. Okay, you identify the pair. H2O is paired with OH minus. Okay, OH minus. Meanwhile, PO4 3 minus is paired with PO4 2 minus. Okay, so first we draw the pair. Okay, so we draw the pair here. Okay, so we can erase here. All right, so PO4 3 minus become HPO4 2 minus. Okay, it shows here that H2O donates its proton to become OH minus. H2O donates its proton, so H2O is the acid. Okay, H2O is the acid, and OH minus will become the conjugate base. Okay, will become the conjugate base. Meanwhile, for the reactant, if we have the acid and PO4 3 minus will automatically be the base. Okay, so this is the base that accept a proton, and when it accept a proton, it will become the conjugate acid. Okay, conjugate acid. So note that base is paired, okay, with conjugate acid, and acid is paired with conjugate base. Okay, that is how you determine, okay, and identify and determine the acid-base conjugate pairs. All right. Next, okay. Next, for question 2, write the conjugate base formula, okay, for the following acids. So, what is the acid that we have here? So, we choose one of the acid. Okay, so let's say I choose 2E. Okay, for question E, N2H5 plus. So N2H5 plus is the acid. So all the species that are given to you is the acid. So we can write acid here. And remember that if we are talking about the conjugate base formula or conjugate acid base pair, so it is the Bronsted-lowry acid base. Okay, Bronsted-lowry acid base. So means that you need to write the equation that consists of the reactant of acid and also base. So if N2H5 plus is the acid, what will be the reactant? What will be the base? So okay, we can take H2O. Okay, the easiest base that we can use is H2O. Okay, H2O is an amphoteric species. It can be either the acid or either the base. If we have the acid, so H2O will be the base, and the reaction is we use the reversible arrow. And remember that N2H5 is the acid, and if the acid act as an acid for the Bronsted-lowry, means that acid will donate its proton to H2O. So proton H plus, so you minus H plus here, then you will get N2H4 plus with H3O plus. Okay, H3O plus. So acid, and the pair is the conjugate base, and base, the pair is what we call as conjugate acid. Okay, so make sure you clear with how we determine the acid base conjugate pair. Okay, so you can try by your own for another species, okay, that we have here. Okay, you can try by your own. If you have any problem, you can ask about the acid base conjugate pairs. Okay, so I think that is all for the theory of acid base.